are literally shaping the planet.
Purpose is the only pathway to a regenerative future.
We have a choice to stay with the status quo or to change.
What is the point of trying to be just resilient when we can actually innovate?
I am going to take a little bit of a roundabout way. As Anastasia mentioned, I'm the Chief Technology Officer at Thornton Tomasetti, and I'm going to hopefully demystify a little bit about digital twins and how it relates to AEC and the environment. So bear with me because it's going to take a little bit of a roundabout way of getting there, but hopefully it will resonate at the end. So a little bit of Thornton Tomasetti again. We're a large firm. We do a lot of complicated projects. Last year I spoke about One Vanderbilt, the middle center, bottom center project being under budget and ahead of schedule, and they actually did that. So that project is opening, I believe, this month. And I'm going to go through some of these introductory slides pretty quickly just to get to the meat of it. I lead a group called Core, and Core Studio specifically, and I'll talk a little bit about that. So we are Thornton Tomasetti's R&D and technology group, and it really is an ecosystem. It's an ecosystem built around driving innovation and change in our industry. And we do that by having a focus and concentration on new technologies and R&D. We've developed many, many tools over the years, software. These are all bespoke, custom software that we've built for Thornton Tomasetti, and a couple, or I should say more than a couple, that are now publicly in the public realm for external use. This is the team, and I sort of put this little matrix together just to highlight we are largely a development team. We have a very strong software development team. Been doing this for 8 years now, and right now it's more, it's less about what tech, but is like what gets prioritized in our office. It's all about ROI. So we're kind of organized in this fashion. So Core Studio being the everyday team, working on app dev and advanced computational modeling. We have a Core AI team, as I mentioned, up above there, led by Badri Hirier. We created the Core AI because we think it's really going to be a significant part of our industry in the next 5 years. So we needed to get on top of that. And of course, we have our office-wide R&D program called Core Lab, which anybody in the firm can offer up an idea, and then if it has some legs, it gets funded. And then for some of the IP, it gets put into our twin company, which is our sort of sister company that manages currently these 6 firms that are external to Thornton Tomasetti, built around IP that was developed at Thornton Tomasetti. There are times when technologies become sort of outgrow what we can use certain technologies within our firm and make more financial sense to spin it off, to release it to the industry as a whole. So let me get into the meat of it. So digital twins. Why is everyone talking about, everywhere you look, you hear about digital twins? And companies like GE talk about digital twins. And the funny thing about all of these is that the first thing they put on all of their slides is they have to explain it, as you can see here, digital twin, right? Because everyone has a slightly different take on what a digital twin is. And I'm going to be very specific about building digital twins. I'm not creating rocket ships. We create buildings, and it's sort of an untapped platform, if you will, for certain types of data and opportunities. So here's IBM talking about digital twins, and as you can see, they have an explanation of what digital twin is, and it's all tailored to their offerings. So, GE might be interested in having sensors to their equipment so that, they can track performance and track and optimize future performance. IBM, I believe, is interested in cognitive learning and recognition. using their very powerful AI solutions. Companies like Azure are very interested in the storage of all that data to sort of drive everyone to their platform. SAP, similar, and you can see every single one of these companies explains what digital twin is, because it's still a relatively new, at least, or not very common technology out there. So let's go back to the beginning. So what is a digital twin? A digital twin is really started back in the NASA days. I'm sure some of you have seen the Apollo 13 movie, or at least read about it. It's a virtual representation of the physical structure in real space and the information flow between the two that keeps the former synchronized with the latter. Very important aspect, which is, and I'll talk about it. Mainly reason why you haven't seen much of digital twins in our building industry, because that aspect of it, the information flow, was not possible even a few years ago, particularly real time. So why is this digital twins and everything around it the future of AEC and many, many, many other industries? Is that the buildings can now become a data platform that is not just monitoring and keeping track of building assets, but everything that goes into the building, including, most importantly, people. So if you're going to have a smart city, you need to know what's going on within buildings. You need to know who's going into those buildings. You need to know what could make people's lives better and more efficient. And especially now with COVID, building owners need to give users and tenants a reason to go back. And I think, everyone's struggling with that a bit right now, but I think that will come. And at the end of the day, there will be real revenue opportunities there. So why is the digital twin, why I think now people are talking about it? Well, one, at least in our industry, mature BIM adoption, reality capture, which is essentially the physical data assets of the building, is now very robust. If you're not doing BIM today, you're probably don't have a business in the design industry or construction. 5G is finally right around the corner, and we will now, instead of getting megabytes per second, we'll be getting gigabytes per second information, which is critical for certain technologies, particularly in the IoT space. You will then have the ability to continuously monitor assets and reduce maintenance costs, see problems before they become a problem, and then improve those systems and efficiencies over time. So also, in order to improve the user experience, you need to have the data of what is driving a good experience versus a bad experience. Right now, it's just a guess, or no one cares because everyone was forced to go to the office. But now, I think it's more important than ever that building owners understand what is driving people to their buildings and their assets. I also mentioned AI and machine learning, and 15 years ago, you could not say that you could do machine learning and AI as readily as you can now. And so that's a significant aspect of why firms like IBM are really doubling down on digital twin technology, because one, they're way ahead of the game, but also everyone will be doing this pretty soon. And then lastly, I mentioned the aspect of people, and people's data is really the cornerstone, in my opinion, of what could drive revenue opportunities in the future. And why? Firms like Facebook and Google, they make their money on people's data. That's essentially what they do. And if building owners or some technology company can come around and have an app that is tracking people's movements, what they do, where they work, what their preferences are, et cetera, in and around the building, that is really important data. For instance, many companies are very interested that I'm a structural engineer, that I work at 51 Madison Avenue, that I'm here on a certain day, that I visit HomeDepot.com quite a bit, right? Because I'm fixing my house. All these things that are relevant to commerce will be very valuable data very soon. And it's focused around buildings or occupants of buildings. So let me get to the environmental part. So this has, I would say, accelerated in the COVID era and also of recent sort of disastrous events that have been happening in the country and the world. So let's just talk about a little about the background. So CO2 emissions, and we've been tracking this for a long time. Industry have been tracking this for a long time. As you can see on the right side here, building operations, 28%. That's sort of like the energy use of buildings on a daily basis. And then of course, what the materials that go into a building. You can see it's about 40% of the world's production of CO2 is in and around buildings. And so that's why there's a huge mandate, or at least there will be, for people in our space to reduce those carbon emissions in buildings, both on the operating side and as well as the embodied energy side, the embodied carbon side. So climate change is a real threat. And the reason why this is now becoming a point of discussion is, when I used to talk about embodied carbon back in 2011, owners didn't give a shit, didn't care. Why? Because it didn't cost them money. Well, now guess what? Embodied carbon emissions is now costing them money. In New York City, it's actually one of the most progressive laws that have been passed in the world. For buildings over 25,000 square feet, there are metrics that if these buildings don't exceed these metrics of energy use, they will get fined, and significant fines over time, starting in 2024, so not too far. And then also the fines increase in 2030. So it's starting to affect their bottom line. And I think US financial markets are seeing climate change as a real risk. And I mentioned this, the CFTC, which is a bipartisan commission, which is why you don't hear too much about sort of the Republican side talking too much about this, because the markets are starting to drive this conversation, and not just parties, for instance. So this is a real issue. It's not going away, and the financial markets will start to drive this discussion. This is some graphs that I grabbed from NASA, and there clearly is a correlation between CO2 and environmental climate, temperature, and if anybody really reads this stuff, the sort of the North Pole and those Arctic regions are really being hit significantly hard. And again, this is not rocket science. This is just basic science. Yes, me. So you just saw today, I just picked this out of the newspaper today. China will become the first, is looking to become carbon neutral by 2060. And they're not just doing this because they're tree huggers. This is a business decision. Carbon trading, which started in the EU, is a real thing. And so there's a real demand for finding carbon neutrality and ways to reduce emissions and embodied carbon in the industry, because there's money there. There's money to be had. So this is a proposal that I produced for New York City. It was not accepted, but I think it will be something in the future. And that is, and just a little bit of background, this little graph here, which is a little small, just demonstrates how a low efficiency building, a medium efficiency building, and high efficiency building had their carbon emissions over time. And then this is a line of carbon emissions. So basically what this says is that the embodied carbon emissions, this black line here, is equal to about 60 years worth of operating energy. Meaning that the structure that I design, if I sort of reduce 5% of the carbon that goes into that building, which is not a lot, which we can do on it easily, represents probably, 10 years worth of operating energy for a building, which is significant, which is why I'm proposing an embodied carbon reduction in addition to what New York City has, which is the reduction of operating energy. The other big aspect is called ESG, if you haven't heard about it, environmental, social, and governance. There has been a lot of studies that show that firms that are focused on these issues, environment, social, and governance issues, outperform other companies. And so therefore, it behooves large companies or any company really to focus on these issues. And obviously environment's part of that. Some of you may have seen that BlackRock, one of the largest asset managers in the world, have doubled down on this issue. And so, again, I get back to this is not just a tree hugger thing. This is real money. It also will impact firms just in terms of, millennials, for instance, who will significantly prefer companies that are focused on these issues than firms that are not, that are sort of old school. So a real issue for us. And so I'm just going to show a little bit of what we've been doing over the years. And just to show that I'm not, jumping on the bandwagon here, I've been talking about this for a long time. This is a presentation that I gave 2012 for our steel conference. And even before that, I spoke at Greenville in 2011 about reducing the structural embodied energy and carbon in buildings. So this is a tool that we developed in 2011. It's called our Embodied Carbon Calculator, which is a generative design tool that Grasshopper was relatively new back then. We wrote some custom scripts to calculate embodied carbon in buildings. And you can filter through a series of design iterations, and it would automatically sort of report the metrics of embodied carbon. And again, back then when I was showing this to clients, they thought I was like an alien. Like, well, what are you doing this for? But at the time we knew that, embodied carbon was a real contributor to global warming. And now it's less of a debate and more of what's going to happen next. And then just to show the progression of this, in terms of how we started leveraging AI, well, that's a lot of data. Like even just that little video that I showed you would probably take hours to do. We sped it up very quickly. And to be honest, if you do one design and filter through all the possible inputs, it would take you literally like years to do. So we started using machine learning back in 2015 to sort of filter through thousands and thousands of design cases to come up with these sort of solutions on the fly, if you will. And this is what it resulted in. It was a tool that we called Asterisk, which you'll be hearing a little bit about soon. We're going to use sort of the back end of the Asterisk machine learning library, which we call Core Learn, and another software, so an external software. So this is a building that we designed in New York City that we're showing how Asterisk can literally design the building to a very early stage design in under a minute, calculating all of the structural elements, foundations, beams, columns, slabs, and cores in under a minute, including the embodied energy. So each one of these iterations gets saved, and you can then start to do some comparisons. Let me go through this, speed through this a little bit faster. You can change materials from steel to concrete, and all that information is stored in a database, and you can see we have some really good data visualizations to show that it's doing some real work there. And so this is a game changer because each one of these iterations would probably take a team of engineers 3 weeks to do. And so, this is just a real demonstration of how AI is will significantly change how the industry works. And to be honest with you, when we was in 2018, even our own firm was a little hesitant to use something like this. But I think those barriers are starting to come down because once engineers know that there's real engineering under the hood, then they'll start to leverage these tools. So we have about 3 years ago, maybe 4 years ago, we built this tool called Spotlight, which is a plugin for Revit, which as a push of a button does a quantity takeoff and a cost estimate and an embodied carbon takeoff for the entire building. So this is the graph showing this VIA West 57th Street in New York City. You can see how this sort of quantity takeoff starts to make sense. we're calculating pounds per square foot of CO2 or kilograms per meter squared, whatever, which we do it both ways, as well as the cost per square foot. So this is it's a cloud-based tool, pushes the information to a cloud. We compare different options, and we track projects during its progression. This started to become a thing, so we released sort of a mini version of this, open source, called Beacon. We have about 500 downloads of this tool. Anybody in the world could use it. Very similar tool. Gives you the options of changing material types and global warming potentials for each material. A data viz of a floor by floor level. A data viz of by element, columns, beams, slabs, floors, etc. And then it compares back to a database from the Carbon Leadership Forum of whether you're green, yellow, or red, sort of within industry standards, below or above, or better. So back to the digital twin, and I'm running a little bit out of time here, but this is how I sort of think the aspect of BIM and leveraging the data that's within BIM can be the beginnings of a very robust digital twin. And it needs to be scalable, it needs to change over time, and it needs to be fast. And so what is the standard for digital twin? And I think that's why every company needs to redefine what it is out there, because there is none. And so what I'm going to show you is like a proposal of what I think could be. So why isn't there one? Well, industry standard platforms like Autodesk Revit, it's really a modeling software. It creates models, but it's not really great for tracking models. They use binary files. The data is closed and within their ecosystem. It's hard to get out. And there are no industry standards. So again, everyone's creating their own solutions. So, a building owner probably does not want 10 solutions tracking 10 different things in their building. They want, a very few that has a very simple data viz of what's happening within their buildings, including the people. And so therefore there's no real value there for building owners because there wasn't any standards. So I'm introducing, this is a tool that we released in 2016. Actually, KP played a big part in this. It's a data platform. It has come a long way. And what it does is take a BIM model and exports data to a central database purely in a data-centric way. So there's no binary files. It's pure data. I'm going to show how that works. And it talks to all these platforms. So this is what we call in the industry interoperability. So it's web and cloud-based, secure, it's essential data repo. It's very much like GitHub for your software developers out there. So it does track changes. You can go back to a previous version, and you can see what people have changed. Again, it's just tracking data. And this is a very common aspect. This is a Cornell Tech project in New York City. It's called the Tata Innovation Center, where we used three, actually more than that probably, but just demonstrating 3 different platforms that need to and live in one model. And that's where we use Konstru. So let me talk about how this relates. So virtual representation in virtual space of a physical structure in real space. That's BIM. That's basically, we already have that in the AEC world. We don't have necessarily is the information flow, sort of the real-time information flow that keeps synchronized aspects of a building. Buildings change all the time. Renovations, the data changes, tenants change, et cetera. Those things need to be tracked in a smart way. Maybe not down to the last piece of drywall, but down to very important aspects of how that building changes. So this is a building, I'm just showing this how we export that data from the Revit model into a data-centric platform just for data viz, and we can track all the elements and the metadata within that model. Again, I'm going to skip through this, but this is really what I'm going to show. All of that, the entire BIM model of that project can be downloaded into an Excel file. The importance of this is that what this means is that the data lives on forever, and unlike binary files. So if you try to open up a Revit 2007 file, if you don't have Windows XP and a version of Revit 2007, you're out of luck. basically. You could update files in Revit maybe every 3 to 4 years, but it's not that reliable. And in this schema, it's purely a data scheme. It's just numbers and text and strings. So what does that mean to a user? A user, let's say a building owner, needs to have a very sharp data viz, clean data viz of what's in that model. So they understand what has changed or what is there. Sort of like, I think of like Google Maps, right? Google Maps essentially is a digital twin of the world, effectively, right? There's a plan view. There is, sort of the satellite view. There's the 3D view, and then there's the person view. Well, a digital twin needs to have all of those things to be easy to use for facilities manager. They're not going to be computational designers using these tools. And go through this really quickly. So what is needed in digital twins is really good data viz, dashboards for those types of things like IoT, an API so that people can customize their platforms to talk to that particular building interface, ownership, data control, privacy, and whoever controls that data is going to be the prize winner here. And of course, custom levels of data interface. Again, I'm just showing some of our tools. We have a 2D tool that does very much the same thing. You need 2D in this world. 3D was fashionable, quite fashionable when 2D didn't exist, but 2D is actually where 90% of the work actually happens in coordination. 3D, obviously, this is our Konstru platform, but it's nice to have. IoT integration, again, the aspect, the 5G aspect, and those types of things has now become real. And then I'm going to just show what we do today. So this is sort of a typical design workflow where we design, use multiple platforms, we use Konstru to exchange data, we issue our documents at LOD 300, we give our documents to the contractor, they create even more data to build the thing, and you can see the facilities manager at the end of most projects gets nothing. They're not even part of the conversation. So my proposal here is to use Konstru. I say Konstru Plus because there's more than Konstru that's needed, is to make that data live on forever to the next phase, which is the operations. And so in a bigger view, there will always be some BIM platform that creates and modifies geometries and data attributes. Push that to the data visualization sort of thread. Then all of these aspects, IoT, apps, system data, building infrastructure can talk to that digital twin. And then the sort of commerce aspects of that can leverage all of that data for either speaking to occupants or speaking to the equipment or whatever that is. So this doesn't exist today, and I think this is where digital twins are going. Thanks.